All right, here we go. I'm going to make the video today on day 2 of implicit differentiation and to do some inverse trig functions in differentiation also. Okay, so first thing I'm going to take care of is I'm going to find dy dx and determine where dy dx is defined. So we're going to differentiate this implicitly. Well, if you notice, we cannot solve for get y by itself, so we cannot do it explicitly, so we have to do it implicitly. Okay, so we're going to differentiate with respect to x. So this is 3x squared plus 3y squared y prime, or dy dx. Today I'm going to write it as dy dx on this one. Okay, is equal to, and here we have a product, so it's the derivative first, which is 1 times dy dx plus, times y. Wow. Sorry about that. Plus the first one, which is x, times the derivative of this, which is just dy dx. Okay? All right. So we need to separate everything or get the dy dx's by themselves. So I'm going to bring them all over to the left and bring all the non-dy dx terms to the other side. So I get 3x squared minus y is equal to, and I'm going to factor it out also, is equal to dy dx times x minus 3y squared. So when I brought it over here, it's going to become negative, and then I factored that out. So dy dx is going to equal 3x squared minus y over x minus 3y squared. Okay? So that is our slope at any point that happens to be on this curve. Okay? Now we need to find out where it is defined. Okay. By doing that is I'm going to show where, first of all, I'm just going to find where it's not defined. And it's going to not be defined whenever the denominator is equal to 0. So I'm going to have x minus 3y squared is equal to 0, which is also saying 3y squared is equal to x. So whenever that relationship exists, we are going to be undefined. So an example of that would be, first of all, you have to find points on there, but it's really whenever this relationship exists. So one way to do it is we could plug it back in, multiply it out, and solve it, but that gets pretty messy.